Hello dear friends, welcome to Gate Academy Global. So before starting today's session, I would like to have the input as well as concurrence regarding the quality of audio as well as video. If it is perfect, just write perfect over the live chat and then we are ready to go ahead. The agenda behind today's video is very same. We are been discussing about the concept of the gain margin and phase margin, and probably today would be the last class for the concept of the gain as well as the phase margin. My agenda is to take around 5 to 6 number of questions in today's class. The first question where the question had been based on the calculation of the gain margin, and in the same way total 7 number of questions we had planned to take in today's class. Anyways, without going to get much delayed, let me focus over the first question first. The problem had been experienced by the electronics people in year of 2003. The problem was framed by IIT Madras. What the problem states? The problem states the gain margin and the phase margin of a feedback system with GSHS is equals to of S divided by of S plus 100, which has been raised to the power of 3 are. The 4 different options were attached along with this problem. The option A had been 0 dB with 0 degree. Option B had been infinity and infinity. Option C had been infinity and 0 degree. And similarly, D had been 88.5 dB, comma infinity. So see, if you will be studying this or if you will be reading this problem, one thing had been quite understandable, and that the gain margin has been calculated in dBs, because I have seen many of the times the student are able to calculate the gain margin, but they do silly mistake. Rather calculating the gain margin in dBs, they calculate the gain margin in linear scale itself. Anyways, read this problem carefully and tell me what could be the best most answer for this given problem. Next 1 minute had been given to you guys. Within 1 minute, you must be able to sort this problem out. You must be able to sort this problem out. So let me do one thing. Let me bring this problem towards working mode. Tell me what would be its best most answer. And till today, probably around 15 to 20 different kinds of the problem had been taken over the concept of the gain margin and phase margin. Even the sort trick is also being revealed to all of you. So probably without drawing its Nyquist plot, without going into its mathematical process, many of the students must be able to get its answer straight away. Tell me what would be its best most answer. And I would request to each one of you, rather going through the complete mathematical process of the gain margin and phase margin, rather going through the complete concept of the Nyquist plot, just analyze the problem within your brain and try to get its answer. Because such a huge amount of questions we have taken in last classes, and at the same time such a sort trick is being communicated to you guys, you must be able to sort this problem out with the comfortable ease. Tell me what would be its best most answer. What would be its best most answer? We had been talking about its gain margin as well as phase margin. This problem had been experienced by the electronics people in year of 2003. The problem was framed by IIT Madras. Tell me what would be its best most answer. So far no answer had come. I don't expect such a lazy way of answering the things, because few number of students had been following me continuously. At least those people must be able to give the answer without giving much delay. Tell me what would be its best most answer. What would be its best most answer? Let me do one thing. Let me take a polar plot. It had been the imaginary axis of the polar plot. It had been the real axis of its polar plot. The angle lines has been 0 degree, minus 90, minus 180, minus 270. As far as this OLTF is being concerned, may I know what would be its initial angle? Sir, because the S component had been present over the OLTF, so obviously at omega is equals to 0, which had been the initial angle offered by this OLTF, is precisely going to be plus 90 degree. So may I know from where it is going to start? It is going to start from plus 90. So obviously this ray or this line had been the plus 90 degree line. Minus 270 is also being referred as a plus 90 degree line. Yes, plus 90 degree line. Plus 90 degree line. May I know what would be its initial magnitude, my dear friend? Once you'll feed omega is equals to 0, put together s also becomes 0, and once the s becomes 0, numerator becomes 0. As the numerator becomes 0, definitely the magnitude would become 0. So what I am saying, without giving much of the thought process, you could have got the value of angle which would be offered by the system as well as the magnitude which would be offered by the system. So magnitude which would be offered by the system at omega is equals to 0 would be simply equals to 0, and similarly angle which would be offered by the system at omega is equals to 0 would be simply equals to of plus 90 degree, plus 90 degree. Similarly, if you'll take omega is equals to infinity, which had been the largest value of omega, may you know what would be the magnitude over there? My dear friend, if we'll talk about the degree of numerator as well as degree of denominator, degree of numerator had been 1, degree of denominator had been 3, and once you'll feed omega tends to infinity, and whenever you apply the limit or the case of limit where the degree of denominator is being larger than the degree of numerator, definitely limit x tends to infinity, omega tends to infinity would feed that function as 0. So may I know what had been the magnitude over there? The magnitude had been simply 0. And may I know what would be the final angle? The final angle is simply going to be 90 within the bracket number of zeros minus of number of poles. How many number of zeros we had? Only one number of zeros we had. How many number of poles we had? The 3 number of poles we have. So simply it's going to be 90 within the bracket 1 minus of 3, that becomes minus of 2. Minus of 2 gets multiplied with the 90, and hence the final angle is simply going to be minus of 180 degree. What does that mean of it? That means initially the magnitude had been 0 and it was taking the reference of plus 90 degree, and it was getting more and more lagging, and at omega is equals to infinity, the final angle had been minus 180 and the magnitude had been 0. Magnitude had been 0. Yes, so what I am saying, so it would look something like this. It would start from 0, the magnitude would increase for a time being, and again it would start decreasing, and it would go like this. It would go like this. Could you really understood what had been the feature of the polar plot? This has been the polar plot. This has been the polar plot. And one of the best thing regarding this polar plot is been omega is equals to 0 plus as well as the omega is equals to of infinity plus had been submerging to the same point because the magnitude was simply 0. The magnitude was simply 0. And now what we are going to do, we are going to extend this polar plot and we are going to draw the complete Nyquist plot itself. If we have been doing so, what we would be doing? We would be taking the segment number 2. The segment number 2 had been the segment from infinity plus to infinity minus, as it has been a proper transfer function that would not exist. And similarly, if we'll talk about the segment number 3, which used to be the inversion of the polar plot itself, yes sir, that would be there, and that has been something like this. That had been something like this. Just a minute. Yes, no, like this it will go. Yes, like this it will go. Just a minute. Just a minute. See what we had been doing over here. You had to just take its inversion. No, you had to just take its inversion. Like this it will be. We can take inside. I think that would be better. That would be better. Like this. Like this. It would be inside. It would be inside. But one of the best thing regarding this complete problem, the maximum magnitude what we had, it's been at omega is equals to 0 is been 0. The maximum magnitude, because of this 100, no, the maximum magnitude would never cross more than 1. And once you'll rotate from its place, no, is still minus 1 plus j0 would not be encircled. And as the minus 1 plus j0 is not getting encircled, forget about the gain margin to be, and forget about the phase margin to be a finite value. There would be extremely infinite value. Obviously, the value is simply going to be infinity. Value is simply going to be infinity. So if we'll talk about how much margin we had over this system to bring this system to the verge of instability, sir, it had been infinity in linear scale. In linear scale. If we convert into the form of dB, so what we are going to do over here, the 20 log base of 10 over infinity, log base 10 of infinity used to be infinity. Infinity gets multiplied with the 20, it again becomes infinity in dBs. And similarly, if we'll talk about the phase margin, my dear friend, the phase margin is again gonna be infinity. Again gonna be infinity. Let me do one thing. Let me show this over an online graph drawer. Online graph drawer. Let's see whether it looks over here or not. Yeah. So here online Nyquist plot drawer, even you can use it. You can use it. The whole from mathematics. So here the function which we are going to take over here, it's been, may I know which function we had been taking over here? It had been s divided by of, just a minute, s divided by of s plus, just a minute, where the plus had gone, here the s plus 100, which has been raised to the power of 3, which has been raised to the power of 3. It is computing its complete Nyquist plot. It is computing its complete Nyquist plot. And the Nyquist plot is almost same as we have drawn over there. Almost same as we have drawn over there. So what we are going to do over here, let me take the screenshot of it. Let me take the screenshot of it. And then we would try to analyze this over the digital board. Yeah, this has been the screenshot. Let me bring this towards the next page, towards the next page. So this has been the complete polar plot, obviously, which had been the extension of Nyquist plot. Like this, like this. Could you really understood what exactly I wanted to communicate through this? And somewhere here, no, somewhere here it had been 0. Somewhere here it had been 0. Yes. So now the same thing has been happening. If you'll talk about -1 plus j0, now again you can take the reference of polar graph paper. The polar graph paper is going to be something like this. Is going to be something like this. So if you'll talk about the -1 plus j0, if you'll talk about the -1 plus j0, it would be somewhere here, -1 plus j0. And if you'll start rotating this, no, if you'll start rotating it from its place, no, what would happen? End of the day, you'll see -1 plus j0 is not going to encircle, and hence the system is going to be a stable system. And hence the system is going to be a stable system. So I would think the concept behind each and individual problem had been very clear to all of us. Agreed now? So tell me whether this concept had been clear to all of us. If the concept is clearly understood to all of us, just write here somewhere. So at least we'll have the better idea. We'll have the better idea. So what I'm saying, if you have this sort of problem, no, just play with the Nyquist plot rather going into the mathematical analysis of the complete problem. Because I have seen the most of the student had got the tendency, whenever in question the gain margin is being asked, what they would calculate, first they would calculate the phase crossover frequency, and with the help of phase crossover frequency they would try to calculate the gain margin. That means they had been very cautious, or they had been very keen to follow the mathematical process, but sometimes the mathematical process would not lead you to the correct answer, because the mathematical process may not be able to find the value of omega GC or omega PC. That's the first thing. And sometime what happens, the calculation with the help of mathematical process becomes very difficult. Agreed now? So I think it's the right time. Just a minute. It's the right time to take the next question. So the next question goes in front of you guys. So here comes the next question. Again, this problem had been experienced by the electronics people. In year of 2002, the problem had been framed by IISc Bangalore. The problem had been 1 divided by of s within the bracket s square plus of s plus of 1. And here we need to find the gain margin. And obviously, the data are being supplied in the form of dBs. That means the gain margin has to be assessed in dBs. Tell me what could be the best most answer for this given problem. What could be the best most answer for this given problem? What could be the best most answer for this given problem? And I would expect the student who had been following me, like Amit Kumar, DS, they must be able to give the answer within maximum to maximum 40 seconds. Maximum to maximum 40 seconds. Tell me what would be the best most answer for this given problem. Perfect. Amit is saying the answer would be B. That's gonna be 0 dB. Bingo. Anyone else apart from Amit? Perfect, Amit. Vignesh, Vicky, the answer had been B. Perfect, Vignesh. Perfect, perfect. DS also says the answer is B. Answer is B. Anyone else apart from the 3 to 4 different kinds of the answers which we have received so far? Which we have received so far? See, it had been communicated probably maybe 5 to 6 number of times. Whenever in this problem, they had been asking about the gain margin. Forget about phase crossover frequency. Forget about the formula which we use for the gain margin. Just a simple step you had to follow. What you had to do? Whatever the OLTF had been given, no, you just multiply that OLTF with K. And with the help of that OLTF, find its characteristic equation. Characteristic equation is being defined as a 1 plus OLTF is equals to 0. Obviously, the GSHS had been K divided by of S within the bracket S square plus of S plus of 1. So that factor has been brought over here. And now when I took the LCM, may I know what would be the LCM over there? The LCM is simply going to be S getting multiplied with the S square plus of S plus of 1. Now what would happen? This factor would get shifted towards right hand side, would get multiplied with 1. So 1 would get multiplied with the S cube plus of S square plus of S, obviously S cube plus of S square plus of S plus of K, because here the factor which would be left out is simply gonna be K is equals to 0. Now we would try to calculate the range of K for the system remains stable. For that we had created a Routh-Hurwitz table. How many number of rows will be there? Within the Routh-Hurwitz, the 4 number of rows would be there because it had been the third order polynomial equation, or I can say it's been a cubic equation. So it had been S cube, S square, S naught. End of the day, if we'll talk about the stability of the system, if the first data had been positive, for keeping the principal column to be non-quantity, there should not be any sign change, and there should not be any sign change indicates the last element indicates the K has to be greater than 0, and similarly the second last row indicates the value of K has to be lesser than 1. So may I know what had been the range of K for system to be a stable system? It has to be this. It has to be this. Now, one of the best thing regarding this problem had been, anyways, if the K is lesser than 1, it's not a gain, no? Could you really understood? My dear friend, if you are saying the input had been 2 volt and the output had been 1 volt, so may I know how much gain? It's not gain, it's been attenuation. So what I'm saying, if K goes against 1 or it goes beyond 1, what would happen? There would be a sign change, and as there has been a sign change, the system would become an unstable system. So as far as this problem is being concerned, the system remained critically stable system at K is equals to 1. Remain critically stable system at K is equals to 1. So may I know how the gain margin is being calculated? The gain margin would simply be 20 log base of 10, and here the K had been simply 1, put together 0 dB. 0 dB. What does that actually mean of it? That means if you'll give an extra gain to this system, the system would become a stable system, unstable system. Could you really understood what had been understanding behind this complete concept? Can we use the formula gain margin is equals to K? Yes. That also you can use. The Dande sir has already been taught that concept. So obviously you can use that also. So the thought process behind this problem must be clear to all of us. The few of the highlighted point which had to be there within our mind whenever the gain margin has to be calculated, forget about the standard process. Just multiply with the K. find its characteristic equation. With the help of characteristic equation, find the maximum value of k for which the system goes to the critical stable system, and that use that value of k, and from there you can get the gain margin, and that had been 0 dB. That had been 0 dB. Could you really understood what had been the thought process behind this complete problem? If the k had gone beyond 1, what would happen? Now the system would be an unstable system. 2 number of pole would go towards right hand side. Obviously, sir, till this point, each and everything is being very clear. Now I would like to ask the next thing. Deliberately what I did, instead 1, I have changed it to 2. I would like to ask from each one of you, in this case, the gain margin in dBs, would it be positive in nature, would it be negative in nature, or would it be 0? I would like to have the input from each one of you. A little bit change had been pushed in this problem. Rather having numerator as 1, we had the numerator as 2, and remaining component remained very same. Now if I'll calculate the gain margin, the value of gain margin in dBs, would it be greater than 1? Would it be lesser than 1, or put together? Tell me. It will be negative. Amit Kumar. Obviously it would be negative. Why so? When you will calculate the value of k with the help of Routh-Hurwitz, the value of k would fall somewhere in between 0 to 1, and once you'll calculate 20 log base 10, the factor which had been somewhere in between 0 to 1, we know whenever the log is being applied over a number where the number is being 0 to 1, the result would always be negative. It would be negative, my dear friend. It would be negative. So the answer have also started coming. As per the Amit, the answer would be how much? Minus 6 dB. That we can check now. See, the same process has to be followed. Only k had got multiplied over this OLTF. So here the factor which had been left out is being 2k. Everything remains same. Instead the k, it's gonna be 2k. And here instead the k, here it's gonna be 2k. Instead the k, here it's gonna be 2k. Instead the k, here it's gonna be 2k. Here it's gonna be 2k. May I know what had been the requirement now? The requirement had been very same. You had to keep all of the element in the principal column to be same in sign. The first element had been positive, so I would keep remaining number of elements which were there over the column to be positive. So may I know what had been the requirement over here? 1 minus of 2k has to be greater than 0, and similarly 2k has to be greater than 0. 2k has to be greater than 0 indicates k has to be any positive value. And now 1 minus of 2k has to be greater than 0 indicates the value of k has to be lesser than half. Put together, the maximum range of k is being half now. So now if you'll calculate, the gain margin is simply going to be 20 log base of 10, and here it is being 0.5. The result had been minus of 6 dB. This minus sign indicates the system had been an unstable system. If you are not able to understand, probably now this is the right time to discuss a bit about the sign of the gain margin as well as its prevalent stability. Agreed? No? What I am saying? So what I am saying, whenever in dBs gain margin is being positive, the system would be categorized under a stable system. And similarly, in dBs, whenever the gain margin is being negative, the system would be categorized under the unstable system. And sometime we have already also seen the gain margin is also being calculated in the linear scale. The concept remains very same. In linear scale, if the gain margin is in between 0 to 1, in that case the system is said to be unstable system. And similarly, if the gain margin is being greater than 1, in that case the system is said to be a stable system. Could you really understood what exactly I wanted to communicate through this problem? See, why in between 0 to 1 the system is said to be an unstable system, my dear friend? That means you cannot offer the extra gain. You had to provide the attenuation to the system such that minus 1 plus j0 would not get encircled. Could you really understood why I am saying if the gain margin is being in between 0 to 1, the system is said to be an unstable system. If the gain margin is being in between 0 to 1, what does that actually mean of it? That means the encirclement is already been made. But now with the multiplier factor, let's take in between 0 to 1, 0.5. If 0.5 is being multiplied to the OLTF, the complete Nyquist plot would get shrink by its half. And now probably minus 1 plus J0 is not going to get encircled. That means you did not have any fundamental phenomena of expanding. Now you have been squeezing the complete system for making it a stable system. Earlier it had been an unstable system, and now by giving the attenuation you had been making it a stable system. So obviously it had been an unstable system. Yes, no? So till this point probably each and everything must be clear to all of us. So I would expect either you can use the concept as the Dande sir has communicated. So probably the student who had been following him on our main channel, you can use that fundamental. Otherwise you can use this fundamental also. You can use this fundamental also. My dear friend, I have seen many of the times we encounter with a cubic equation, and with the help of that cubic equation usually we had to find the stability of the system. So I think you can remember a short trick. Let's take, we have a cubic equation that had been a cube s to the power of 3, a cube s to the power of 3, a2 s square, a1 s, and here the last term had been a naught. Last term had been a naught. Let me draw the Routh-Hurwitz table. Let me draw the Routh-Hurwitz table. I have presumed a3, a2, a1 and a naught, all of 4 coefficient over this cubic equation had been greater than 0, not including 0. That means none of the term had been missing and all of them had been positive in nature. All of them had been positive in nature. Let me start feeding the data over here. So this row would be dedicated towards s cube. Here goes s square, here goes s, and here goes s has been raised to the power of 0. Let me start placing the coefficient over here. It's been a3, here it goes a2, here it goes a1, and here it goes a naught. Here it goes a naught. Yes, no? Agreed? May I know what would be the data over here? The data is simply going to be a2, a2, a1, and here it's going to be a3, a3, a0, and towards denominator side we are going to have the factor as a2, and here the factor is simply going to be 0. Here the factor is simply going to be 0. We can do like this. Here the factor we had is simply 0, and the last data is simply multiplication between them minus multiplication between them divided by this factor, and we are going to get the a naught itself. So what's the conclusion we wanted to bring out of it? See, it had been clearly said that the a3, a2, a1, a naught, they had been the real value greater than 0. So obviously the sign of the first element over the principal column had been positive. Here also it's been positive, and here also it's been positive. For making this system to be a stable system, what do you exactly want? Even the a2 is also being positive, So you just want only one thing, and that had been a2 into a1 minus of a3 of a naught. A naught has to be greater than 0. And if it happens, the system would become a stable system. If I take its corollaries, like if a2, a1 minus of a3, a naught is not been greater than 0, or I can say it's been the lesser than 0, in that case the system would be an unstable system. How many number of sign changes would be there in that case? Obviously 2 number of sign changes we are going to experience, or I can say towards right hand side, two poles are going. And similarly, if I say a2, a1 minus of a3, a0 is being equals to 0, in that case the system is going to be a critically stable system. is gonna be the critically stable system. Could you really understood what exactly we had been talking about? That means in future, whenever you have the cubic equation in terms of characteristic equation, you need not to follow the complete process which we follow in case of Routh-Hurwitz. Just do the multiplication, and the multiplication has to be done between the first and last element, and similarly the intermediate elements. Yes, and the process which we had to follow, first we had to multiply them together and then we had to subtract them. The result is there in front of you. Result is been there in front of you. Yes, or you can simply say if their multiplication had been greater than the multiplication between them, the system is going to be stable. If the multiplication between them had been lesser than the multiplication between them, the system has been an unstable system. If the multiplication between them had been same as the multiplication between the first and last, the system is going to be marginally stable system. Could you really understood what I'm saying? So let me do one thing. Let me take on a problem. So here we have a cubic equation s cube, and here we had 4s square and 1.5 times of s, and here we had, let's take 8 is equals to 0. Tell me whether it had been a stable system, whether it had been an unstable system. It had been the first question for you guys. So obviously without following the complete process which we follow in case of Routh-Hurwitz, just by using this sort trick, you must be able to crash this problem out. Tell me what would be the answer over there. What you had to do, you had to just multiply this two factor. May you know what had been the multiplication between them? The multiplication between 4 and 1.5 had been 6. And similarly, if we'll talk about the multiplication between 1 and 8, that had been 8. And the 6 had been lesser than 8. So obviously the system had been an unstable system. Because as per the requirement of the stable system, the multiplication between the two middlemost values must be greater than the multiplication between the two extreme left and right values. Yes, no? So till this point, probably each and everything must be clear to all of us. Let me take one more problem, and probably with the help of that problem, you must be able to understand the crux behind the sort trick which had been communicated just now. Now, the next thing, just try to understand in this way. We had the s cube over here, and here we had 4s square, here we had 2s, and here we had 6 is equals to 0. Tell me whether it had been a stable system, whether it had been an unstable system. Has it been a stable system? Has it been an unstable system? Obviously, sir, it had been a stable system. How did I know about it, sir? It's quite easy, sir, because we had just been multiplying 4 and 2, that had been 8, and we had just been multiplying the coefficient of s cube as well as s naught, and that had been 1 into 6, that had been 6. Obviously, the middlemost multiplication had been greater than the extreme multiplication. The system is going to be kind of a stable system. Till this point, I don't find any of the student would have any kind of doubt now. So why I am revealing this sort trick? Because most of the time you come across a characteristic equation which used to be cubic in nature. So rather going it to the complete analysis over the Routh-Hurwitz table, you could have taken its alternate. Could you really understood what exactly I had been talking about? Could you really understood what we have been exactly talking about? Yes, sir, we had been exactly talking about this also. Yes, no? Now let me take the last, never the least. So here we take s cube. Let's take it's been 4s square plus of s, and here it goes 4 is equals to 0. S cube 4s square, s plus 4 is equals to 0. Now what we are going to do over here, just try to figure it out what we have been doing over here. See, once we'll do the multiplication, no, you yourself would be able to understand, sir, intermediate multiplication is being 4 and extreme multiplication is also being 4. 4 is equals to 4. The system is gonna be a marginally stable system. And whenever the marginally stable system do pursue in this case, no, there would be the complex conjugate pole over the j omega axis. Anyways, let me check this out. So the first row would be dedicated towards s cube, goes to s square, goes to s and ends up to the s naught, ends up to the s naught. Let me start feeding the data. So here the first data had been 1 and the next data it's been 4, the next data it's been 1, next data it's been 4. It had been communicated earlier, whenever a positive real quantity is being common in either of the row, you can just extract that out. So what I'm being doing over here, we had just divided this factor with 4. So it had been 1 over here, it had been 1 over here. Many of the students who might be watching my video first time, they may not be able to understand why this had happened. Just take one thing as guaranteed: whenever something common is being found in the complete row, that you can extract it out, or you can just divide with the same factor. The factor which had been left out is being simply this. Okay, now what we have been doing over here, we had to process follow. So now the 1 gets multiplied with 1, that becomes 1 minus of 1 divided by 1. So numerator had been 0 and towards denominator we had 1. 0 by 1 we had the factor as 0, and that is supposed to be because A2 A1, the multiplication between A2 and A1 had been very same as the multiplication between A3 and A0. So obviously this factor is supposed to be 0. So what we are going to do, we are going to get the auxiliary polynomial and then auxiliary equation. May I know what would be the auxiliary polynomial? Either you can take the auxiliary polynomial as a 4s square plus of 4, even you can take s square plus of 1 also, because in both of the cases there would not be any change. If you don't understand, let me show that. So either you can take 4s square plus of 4 as the auxiliary polynomial. Yes, otherwise you could have taken, because the 4 had been ruled out, s square plus 1, s square plus of 1. Anyways, we would take its first differentiation. If we'll take its first derivative, the factor which is going to come, it's simply going to be 8s square. 8s, sorry, not square. 8s, and here it's simply going to be 2 of s. 2 of s. Either you feed 8, either you feed 2, does not make any sense. Because even if you'll feed 8, no, then also even you could have divided this complete row with 8, and the factor which had been left out is been simply 1. And similarly, if you'll feed 2 also, then also no problem, you can divide this complete row with 2 and still the row would be fed with 1 only, Could you really understood? Anyways, this is not the right time to discuss about the Routh-Hurwitz criteria and all, because that portion is already been covered earlier. So the student who had followed me definitely had a little bit idea how the complete process had been following so far. Otherwise, the student who had been following my lecture first time, they can refer my older lecture. So okay, I would go ahead with the traditional method. Here the data which we are going to feed is simply going to be 8. And may I know what's going to be the last data? The last data is going to be 4. There had not been any sign change. And I will ensure you there would not be any sign change. If this and this, the 4 number of polynomial which we had known, or coefficient which we had, if all of them are positive, there is no other way, there cannot be any sign change over the first column on the Routh-Hurwitz. That means the system cannot be unstable at any cost. Could you really understood what exactly I had been talking about? And similarly, if you take the reference of 4s square plus of 4, and with the help of this auxiliary polynomial, let me create an auxiliary equation. And once we create an auxiliary equation, easily we would be able to find the locations. And may I know where the locations would be? Plus minus of j, or I can say the natural frequency of oscillation. What we have got for this problem is been omega n is equals to of 1 radian per second. 1 radian per second. Yes, no? So till this point, I don't find any of the student would have any kind of doubt now. I think it's the right time to move further, taking the next question. And it had been a sort of graphical problem which had been experienced by the electronics people in engineering services examination year of 1999. The problem states, the portion of the polar plot of an open loop transfer function is shown in the figure. The phase margin and gain margin will be respectively. The 4 different options were attached along with this problem. 30 degree 0.75, 60 degree 0.375, 60 degree 0.75 and D had been 60 degree with 1 divided by 0.75. 0.75. So the student who had a little bit conceptual understanding regarding the phase margin and gain margin easily would be able to crack this problem out. So tell me what would be the best most answer for this given problem. For this given problem. So let me bring this problem towards working board and we would try to smash that problem there itself. There itself. Tell me how much answer we are going to get over here. How much answer we are going to get for this particular problem. This problem had been sort of this. This problem had been sort of this. This degree, 30 degree, which they had been representing, no? Basically, they had been taking the reference of a negative imaginary axis. Yes. This angle precisely had been marked as a 30 degree. 30 degree. Tell me what would be the precise most answer. What would be the precise most answer? So the answer have started coming. As per the Amit, the answer would be D. As per the Jatin Chabra, the answer is being D. Vignesh, Vicky, the answer is being D. Anyone else apart from the 3 number of answers which we have received so far? See, first of all, let me focus over the stability of this system. Tell me whether it had been a stable system or unstable system. Obviously, -1 plus J0 has not been encircled so far. So at least we had been relaxed in that sense. The system had been a stable system. Had been a stable system. Now the next thing. When we would start giving a lag to the system, after certain amount of lag, -1 plus J0 is going to get encircled. That means phase margin is gonna be a finite value. Not only that, even once we would start pushing the gain into the system, this complete polar plot would start getting bulged from its place. That concept is already been communicated in last class as well as last to last class. So once the gain would be start giving to the system, it would start getting bulged, and once the system is started getting bulged, again -1 plus J0 is supposed to get encircled. That means the phase margin is also gonna be a finite in nature. So that is why I am saying, out of A, B, C, D, the 4 different options were given. If in either of the option, either the gain margin or the phase margin must have been given as infinity, that option must have been ruled out, because phase margin and gain margin both had been a finite value. Agreed? Now, how the phase margin is being given? How much lag we can provide to the system such that the system would become, or system would reach to the verge of its instability. So what we are going to do, we are just going to give the lag to this complete system. So what it's been happening, this has been the polar plot, no? This point, no, it would start dislocating from its place. Obviously, it would start dislocating from its place. It would go like this. Yes, it would go like this. How much angle had been left out? Such that this point that had been the critical point. Why I am calling it critical point? Because here the magnitude had been 1, and in future, if you will be keep rotating this polar plot into the in clockwise direction or in lagging phase, this point would start intersecting at -1 plus J0. And if you will provide lag more than this, the system would become an unstable system. So obviously, my dear friend, this angle had been the phase margin. How much margin had been left out with the phase? This has been 30 degree. This has been 90 degree. And we know very well, 90 plus 30, the remaining angle is going to be the phase margin. How much angle we are going to have in totality? 180. 180 minus of 90, that's simply 90. 90 minus of 30, that's simply 60 degree. So the phase margin is simply going to be 60 degree. If you're not able to digest how did I exactly do it, you could have used the basic mathematical procedure for finding phase margin. The phase margin is being defined as 180 degree plus of angle offered by the system Gj omega Hj omega at omega is equals to of omega Gc. What does that mean by the omega Gc? The omega Gc is being the operating frequency at which the gain offered by the system is being simply unity in linear scale or 0 dB in logarithmic scale. So you yourself would be able to understand this point they have marked as a -1. That what does that mean of it? That means the radius of this circle is being 1, or I can say it's been a unity constant circle, unity constant circle. So obviously here this has been the frequency where the value of omega has been omega gc. At omega gc you had found the angle. How much angle it had been? It had been minus of 90, minus of 30, that had been minus of 120. Why I have taken the angle as minus? Because we had been counting the angle into the clockwise direction. Whenever the calculation is being taken clockwise, we used to refer that angle as a minus. So here the answer which we have found, it's been 60. Answer which we have found, it's been 60. And at the same time, if we'll talk about the gain margin, just try to understand in this way. While calculating the gain margin, I cannot give any of the introduction of the phase shift. No, I can't. Only and only I can keep push the values of gain. And as we have been keep pushing the gain, no, what would happen? It would start getting bulged. It would start getting bulged. Yes, sir, we are able to understand it. See, when the standard transfer function we had, no, may know the intersection over the negative real axis where it was at 0.75. It had been at 0.75. Let's take the system is being GSHS. The system is being GSHS. The K had been multiplied separately. When the K was 1, the intersection of the given system at negative real axis is being at minus of 0.75. Let's do one thing. Let's increase K a bit. If you bring the K as 2, what would happen? Do you know that? Now this intersection would not be at minus of 0.75. It would be at minus of 1.5. And the system would become an unstable system. So may I know when the system would just become to the verge of instability? 0.75 has to be multiplied with certain thing such that the result would become exactly 1. So may I know what would be that factor? It would be simply 1 divided by 0.75. 1 divided by 0.75. How much gain margin is being left out? It's been 1 divided by 0.75. Obviously, it would be greater than 1 only. 0.75 had been inverted. 0.75 had been inverted. 1.33 or 1.3 bar. 1.3 bar. And as you provide the gain as 1.3 bar, no, precisely it would be crossing through this. It would be crossing through this. Sir, but still after 60-degree lag, the point -1 will not be enclosed. So how it will be unstable system? Who said, my dear friend? After 60-degree, no? After 60-degree, what it's been happening? It had been keep rotating from its place. The gain had been infinity. That means what I'm saying, this curve had been started from very lower side and you had been keep rotating from its place. What would happen? After some time, what would happen? It would be like this. It would be like this. And obviously the encirclement had been taking place. So from here, one of the important point I would like to bring in front of you. Phase margin, how the formula is derived for the phase margin is already been communicated in the last class. Nobody had to by heart the formula because until and unless the basics behind any of the formula is not known, no, probably the student would not be able to digest the concept easily. How the phase margin formula is being derived, it has been communicated in the last class. Let me focus over the gain margin. How the formula for the gain margin is being derived. See what's been happening. In case of the calculation of gain margin, I cannot introduce any of the additional phase change, either in terms of lead, either in terms of lag. So what it's been happening, it cannot rotate from its place. No, it can't. That means whatever the polar plot you had the same polar plot. But in future, if you will be providing the gain, no, it would start bulging from its place. That means this point would start dislocating in negative real axis point. This point would start getting dislocating from its negative real axis point. Yes, no? And as it has been dislocating from its negative real axis point, how much dislocation is possible such that the system reaches to the verge of its, I repeat, system which would reach to the verge of its instability. So what I would do? I would just calculate the distance from the origin. Let's take its B. And what I would do, now this B has to be given certain gain such that the gain into B becomes 1. I repeat, the gain into B becomes 1. So here gain into B becomes 1. And that gain is nothing but the margin in gain, or I can say That gain is nothing but the margin in gain. So the gain margin is simply equals to of 1 upon B. Gain margin is simply equals to of 1 upon B. What had been the B over there? The B had been, I repeat, B had been the magnitude offered by the system when, when it was crossing through the minus 180 degree, or when the angle offered by the system was minus 180 degree. So what had been the B over there? The B had been the magnitude offered by the system G j omega H j omega at which frequency? The frequency at which the angle offered by the system was precisely 180 degree. Could you really understood what exactly I wanted to communicate through this? So may I know the concept behind the phase margin, gain margin, the formula from where the phase margin and gain margin formula has been deduced or derived must have been clear to all of us. So I would like to have the input from each one of you. The formula from where the gain margin as well as phase margin has been deduced, is it clear to all of us? Is it clear to all of us? How it had become phase margin is equals to 180 degree plus of angle offered by the system at omega is equals to omega GC, where I used to refer the frequency at which the gain offered by the system is being unity. And similarly, why the gain margin is being taken as inversion of the magnitude offered by the system at omega is equals to of omega PC, and why while calculating the gain margin I used to take the reference of phase crossover frequency. So probably this concept must have been clear to all of us. So tell me, the formula which we have derived for the gain margin, is it clear to all of us or not? Amit Kumar, yes sir. Good dear. Now, again, if B is being greater than 1, what I am saying, B is being greater than 1, in that case, the system is being an unstable system. And for making it a stable system, the gain has to be lesser than 1. And that is why it would be keep squeezing its structure, and end of the day the system would become an unstable system. That is what I am saying. No, that is what I am saying. When the system is gonna be a stable system, if B is being in between 0 to 1, gain margin would be greater than 1, system would be a stable system. When B was greater than 1, in that case the gain margin is in between 0 to 1, system is gonna be an unstable system. And in linear scale, if the gain margin is greater than 1, in dBs it's gonna be greater than 0, and similarly in linear scale, if the gain margin is in between 0 to 1, in dBs it's gonna be lesser than 0. It's gonna be lesser than 0. So probably till this point, I don't find any of the student would have any kind of doubt. So from here onwards, take two things for granted. Whenever the phase margin has to be calculated, I take the reference of omega GC. Omega GC is nothing but the intersection of your polar plot from a unity magnitude circle, because once you'll rotate from its place, no, when this complete polar plot would start getting rotating from its place, this is the polar plot would keep shifted and would strike to the minus 1 plus j0. So how much margin is being left out? It's nothing but the margin which has been left out in terms of phase lag phase margin. Similarly, in future, when the gain would be keep pumping, what would happen? This point would be keep shifting from its place towards the left hand side, and probably the minus 1 plus j0 is going to go into the danger. That is why I used to take the reference of this operating frequency, and this operating frequency is the frequency at which the angle offered by the system is being minus 180 degree. So the gain margin would take the reference of phase crossover frequency, and similarly phase margin would take the reference of gain crossover frequency. So this has been the basic concept behind the gain as well as phase margin. Let me do one thing. Let me go forward. Let me take the next question now. Here comes the next question in front of you, and probably without spending much amount of time, you guys must be able to crack this problem out. This had been the problem which had been experienced by the electronics people in engineering services examination year of 2000. Tell me, what would be the best most answer over here? What would be the best most answer over here? The problem states the polar plot for the positive frequencies. Obviously, if they had been talking about the polar plot for the positive frequency, we had been talking about the polar plot itself. for the open loop transfer function of a unity feedback control system is shown in the given figure. The phase margin and the gain margin of the systems are respectively. Nothing has been given with the gain margin. That means they had been talking about, or they had been asking you to calculate the gain margin in linear scale. Tell me, Amit had given the answer. As per the Amit, the answer would be A. Anyone else apart from the Amit? Anyone else apart from the Amit? DS, you are also following me continuously. Your answers are getting delayed. You must be much faster. You must be much faster. See, this angle had been 30 degree. This angle had been 30 degrees. So the remaining angle is simply going to be 150 degree. So may I know what had been the margin in phase which had been left out over this system? Obviously, sir, this has been the margin in phase which had been left out with the system. And simply that is going to be 150 degree. That is going to be 150 degree. Option C is been ruled out. Option D is been ruled out. Option D is been ruled out. Similarly, if we'll talk about the gain margin, this has been the factor of B. If we'll talk about the gain margin in linear scale is simply gonna be 1 divided by of B, and simply here it's gonna be 1 divided by of 0.25, and hence the answer is gonna be 4. The gain margin in linear scale is being 4, and the phase margin is simply gonna be 150 degree. 150 degree. So may I know what's gonna be the best most answer? So the best most answer is gonna be A. Best most answer is gonna be A. See what is been happening? So if you'll be keep pumping the gain, what would happen? This structure would become sort of this. This structure would become sort of this, like this. Like this. And when the gain had been precisely 4, what would happen? You yourself would be able to predict this well. The curve would be like this. The curve would be like this. Like this. And if you pump gain more than this, what would happen? Now the minus 1 plus J0 would start getting encircled. And that is why the gain margin has been pretty 4. And similarly, if we'll talk about the phase margin had been precisely equals to 150 degree. System had been a stable system with a good amount of gain as well as phase margin. With a good amount of the gain as well as phase margin. So obviously this must be clear to all of us. I think it's the right time to take the next question. Here goes the question number 5th. So let me bring this problem towards the working board, and then we would try to smash this problem out. This problem had been experienced by the instrumentation people. In year of 2014, the problem was framed by IIT KGP. Read the problem carefully and tell me what could be the best most answer for this given problem. The loop transfer function of the feedback control system is given by, just a minute, whether it's been the complete, okay, it's phase crossover frequency they had been seeking for. We had to calculate the phase crossover frequency for this given system. Find the phase crossover frequency for this given system. And this has been a type of NAT. That means the answer has to be given in a form of numeric inputs. Tell me what would be the answer for this given problem. The phase crossover frequency is being asked over this problem. Amit Kumar, perfect. 0.333. That's been the perfect answer. Anyone else apart from the Amit Kumar? See, what does that mean by the phase crossover frequency? The frequency at which the angle offered by the system is precisely minus 180 degree. So what we could have done, because of 1 upon s, always there would be the introduction of minus 90 degree irrespective of the operating frequency omega. So angle offered by this system is equals to of minus 180 degree. Angle offered by the 1 upon s would be minus 90. Minus 180 plus of 90 would become minus of 90. Just focus over the angle offered by this system and compare with the minus of 90. That we can do. May I know what would be the angle offered by this system? That's simply gonna be minus of tan inverse, and because of that it's gonna be j omega plus of 1, imaginary part that had been omega divided by of real part that had been 1. So simply it's gonna be tan inverse of omega, and here it's gonna be minus of tan inverse 9 omega. 9 omega, that's it. 9 omega. And here it had to get compared with the minus of 90. Minus, minus, minus had been knocked off. And now what we are going to do? We are going to use a inverse trigonometric identity. Tan inverse of A plus of tan inverse of B. May I know what used to be the result of it? The tan inverse A plus of tan inverse B used to be tan inverse of A plus of B divided by of 1 minus of A into B. If it has been plus, here also it would be plus, but towards the denominator side, it would be minus. If it would have been minus, here it would be minus, but here it would become plus. So here it had become omega plus of 9 of omega. Here it's been 1 minus of 90. Agreed, no? So when the tan inverse is being placed towards the right hand side, it becomes tan of 90, and we know the tan of 90 is an absolutely large value, hypothetically infinity. So what we could have done over here, we could have taken inverse both other sides. And once we do so, the denominator would go towards numerator side. It had been 1 minus of 9 omega square, and numerator would come towards the downside. And 10, 90 becomes infinity, inverse would become 0, 0 would get multiplied with the 10, omega would become 0, 1 minus of 9 omega square would become 0, and now from here the omega is being 1 upon root 3. So here omega is being 1 over root over of 9, 1 upon 3, and the answer which we are supposed to get, it's gonna be 0.3 has been raised to the bar, So obviously the answer which we are supposed to get over this problem is being 0.3 bar. Agreed, no? I think this problem must be clear to all of us. Yes, sir? Okay then, let me move forward. Let me take the next question which comes in front of you. The problem had been experienced by the electronics people in year of 2016. The problem was framed by IISc Bangalore. Let me bring this problem towards working board and we would try to smash that problem there only. In the feedback system shown below, GS is being 1 divided by s plus 1, s plus 2, s plus 3. The positive value of k for which the gain margin of the loop is exactly 0 dB and the phase margin of the loop is exactly 0 degree. Yes. Tell me, what had been the basic concept behind this problem? My dear friend, they wants to have a certain situation in which the gain margin as well as phase margin both had been precisely 0 dBs as well as 0 degrees. In that case, you had to find the value of k. It is not that difficult question. If you really understand the crux behind this problem, no, probably you would be able to manage this problem very well. In this problem, they had been talking about the gain margin is being 0 dB and phase margin is equals to of 0 degree. That means the type of system, it's been a critically stable system. What does it mean by the critically stable system? That means the closed loop poles are being placed over the j omega axis. Although it had been a stable system, but is still a little bit more gain, the system would become a unstable system. Could you really understood what I am saying? Many of the students would like to calculate the gain margin as well as phase margin, or they would try to follow the complete mathematical process which they follow in gain margin and phase margin. You need not to do so. In this problem, they had been clearly said the loop gain is being 0 dB and similarly the phase margin is being 0. That means the system is being a critically stable system. And if the system is being a critically stable system, one thing has been quite sure, the j omega axis is going to have the pair of poles. Could you really understood what I am saying? In the second step, what we could have done over there? In the second step, we would create the characteristic equation, which would be cubic equation. So it's simply gonna be 1 plus of k times of GSHS is equals to 0. obviously this factor is supposed to come over here, and this denominator is straight away going to get multiplied over here. May I know what would be its multiplication factor? It's simply gonna be, just a minute, it's simply gonna be s square plus of 3 of s plus of 2 getting multiplied with s plus 3, and here it would come as k. Here it would come as k. In next step, it would become s cube. Yes, it would become s cube. It would become 3s square. It would become 2 times of s. It would become 3s square. It would become 9 times of s. It would become 6 plus of k, and here it would become 0. Here it would become 0. Let me do one thing. Let me consolidate all of the like terms. S cube, the degree of 3, only one term we had. So here if we had been s cube, 3 plus 3, that had been 6s square, and then 9 plus 2, that's been 11 times of s, and here we had 6 plus of k. Again, one thing has been quite sure, all of the coefficient which were attached with individual terms had been positive in nature, and if we want to keep this system as a critically stable system, the multiplication between these two coefficients must be very same as the multiplication between these two coefficients. Yes, no? So may I know what had been the multiplication over there? It's been 6 plus of k going to get multiplied with 1. So obviously the resultant had been 6 plus k. 6 plus k. And here 11 going to get multiplied with the 66. Yes, no? So here it becomes 66. The k had been simply equals to of 60. Such a smallest frame of the problem it was. Such a smallest frame of the problem it was. But until and unless the student are not aware with the concept of the gain margin and phase margin, students are not aware with that the gain margin can also be connected with the characteristic equation, and the characteristic equations pole would be located over the j omega axis. Probably they would not be able to sort this problem out. Sir, what are the different changes come if pole 0 added in CLTF? Anil, I would do one thing when I would be talking about the root locus. No, specifically there I would be showing how the addition of the poles as well as the zeros affect the structure of the root locus, and with the help of the structure variations over the root locus, you would be able to understand each and everything. Anyways, lump sum I can say, whenever the pole is getting introduced over the system stability is always been decreased. Whenever the zeros are being introduced within the system towards the left handmost side of the complete zeros as well as poles, the system stability increases. So what I can say, if pole increases, always system stability decreases. If zeros increases, sometime it increases, sometime it decreases, sometime it decreases. So may I know till this point each and everything is clear or not? Probably this must be clear to all of us. And such a well-framed problem it had been. Such a well-framed problem it had been. So the student who are not having the good idea about the gain margin and phase margin, because I have seen whenever gain margin or phase margin do come, no, the student thinks, sir, the gain margin and phase margin is something very different, which is not at all related with the characteristic equation or the locations of the closed loop pole. So in that case, they would not be able to attack this problem. They would not be able to attack this problem. Yes, no? So I think it's the right time to move forward, and let me take the next question and probably the last question of the day. This sort of problem had come 3 times in all 3 papers. That means the instrumentation as well as the electronics people have also experienced the same problem, and that had been the problem which had been experienced by the electrical. In year of 2004, the problem was framed by IIT Delhi. Let me do one thing. Let me bring this problem towards working board, and we would try to smash that problem there. Read the problem carefully and tell me what could be the best most answer for this given problem. The problem states the open loop transfer function of a unity feedback system is given as gs is equals to of as plus 1 divided by f square. The value of a to give a phase margin of 45 degrees equals to the 4 different options were attached along with this problem. Along with this problem. Again and again I am saying the same thing. Whenever you are about to attack the problem, no, at least have a prediction of the next 3 to 4 number of steps. Have the at least prediction of the 3 to 4 number of steps, because starting 3 to 4 number of steps makes hell amount of sense for either of the questions. Because if they starting 3 to 4 number of steps, so the approach had been appropriate, no, probably you are going to smash that problem with a minimalistic approach, and at the same time the accuracy would also be higher. In this problem, they had been given that the phase margin which has to get extracted from this system has to be 45 degree. What does that mean of it? The phase margin is being defined as, just try to understand what I'm saying. The phase margin is being defined as 180 degree plus of angle offered by the system gj omega hj omega at omega gc, and in this problem it had been clearly said we had to find the gain margin, phase margin to be plus 45 degree. So may I know what's the conclusion we can retrieve out of it? That means at omega is equals to of omega gc, or at gain crossover frequency, the angle offered by the system must be precisely minus of 135 degree. Minus of 135 degree. In the next step, let me go forward. May I know what would be the angle offered by the system? Because of 1 upon s square, obviously the angle offered by the system would be minus 180 degree, and it would be independent from any operating frequency, whether you take omega is equals to 0, omega is equals to infinity, or any of the intermediate frequencies. Because of the factor 1 upon s square, always there would be the introduction of minus 180 degree, and because of a is plus 1, there would be the introduction of the angle as minus of tan inverse of a omega, and now this angle had been given as minus of 135 degree. Now 180 with a minus sign gets shifted towards right hand side, would become plus of 180. Plus of 180 gets subtracted with a 135, would become 45. Tan inverse of 45 would become 1, or I can say the A is simply gonna be 1 upon omega, where the omega had been omega gc. Yes, no? Till this point, I don't find any of the student would have any kind of doubt now. So now the next step is going to be just focus over the omega gc. Omega gc, the frequency at which the gain offered by the system becomes unity. Yes, no? Unity. So till this point, each and everything must be clear to all of us. Tell me what would be the best most answer which we'll get in. Anyways, see, here we have got this relationship at omega gc. A into omega gc had been precisely 1, or simply A into omega could have been written as 1 itself. So here it becomes 1 which has been raised to the power of 1. 1 had been 1 only, and here it had been omega square. Yes, sir, we are able to understand it. And from here, how much answer we have got it, my dear friends? So let me do one thing. So omega square is equals to of 2 had been raised to the power of 1 by 4. Is it? Calculate this and tell me what would be the best most answer which we would be able to get out of this complete calculation. Root over of a omega has been raised to the power of 2 plus of 1. Omega square is, everything is fine. So here it had been 2 has been raised to the power of 1 by 4. It's been 1.189, and now we had to take its inverse. It had been 0.841. The answer had been C. Yes, no? So from here, either you could have got the relationship between A and omega gc, but A into omega gc had been coming together in this expression. So why don't we feed A into omega gc is been 1. Once we fed that value, the value of omega which we got over here, is been how much it had been? Just a minute. Mm-hmm. Let me take the inverse once again. This has been, omega had been 1 point of 189, and hence the value of A is simply gonna be 1 divided by 1.89. The result which we are supposed to get, it's been 0.840. I would like to have the input from each one of you. I would like to have the input from each one of you from the next or the tomorrow's class onwards. Which topic I should start? Which topic I should start? Because definitely the part of gain margin and phase margin is over from my side. Still, few of the difficult questions are being left out, but I think it's your responsibility to look into those problems. And if you have those sort of doubts, you can come to my Telegram group and you can put the doubts over there. If time permits, definitely I would try to bring those questions as the separate video. Tell me which topic we should start from the next video onwards. Tell me, dear friends. Bode plot. Amit is saying Bode plot. Anyone else apart from the Amit? Thank you, dear Jatin. Jatin, I would like to ask one thing. From next video onwards, which topic we should start now? So the three options I am giving to you guys, either it could be root locus, either it could be Bode plot, either it could be state space analysis. Okay, varieties of the input have started coming as per the Amit, Bode, as per the DS, state space. Anyways, we will see tomorrow. Anyways, from tomorrow onwards, we are going to start the new topic. Probably it could be state space, it could be Bode plot, or it could be root locus. Okay? Okay then, root locus. See, that had been the third option. I know. I was waiting for the Vignesh reply because probably 3 to 4 days back, his point was root locus only. Jan also is saying root locus. No issue. Probably we are going to start the root locus from the next video onwards. And Amit, you need not to get disheartened. After root locus, I would take the Bode plot. Yes. So I think this is all about the today's class. We would meet tomorrow at the same time, 3 p.m. with the same enthusiasm, with the same concepts. Till then, bye-bye. Take care.